Write each solution as a fraction unless otherwise indicated. 1 mark each. It says, a bag contains 10 red, 6 green, and 5 white marbles. Determine the probability of the following if 2 marbles are selected. That the first one drawn is white, and the second one drawn is white, given that the first one drawn was white and there was no replacement. I was going to do a tree with 3 sections, red, and then green, and then white. But since I noticed, Justin, that they're asking about white each time, I took a shortcut. I said my tree is going to go like this. White, not white on the first draw. White, not white on the second draw. White, not white on the second draw. You could have gone red, green, white, and then red, green, white, whatever. That was just me being clever, and I said, oh, how many whites? 5 out of how many? 10, 16, 21. You know what? This is 5 out of 21, and that would make this 16 out of 21. Down here, you picked a white one, so now it's 4 out of 20. You know what? I can stop there. Not 4, Mr. Dueck. 5 out of 21. Now, this is not a conditional probability from last day. This is not them telling you the bottom row and saying go upwards the top row. Oh, that's both over the given one, although I think that would actually get you there. The answer is just that's the probability that the second one's white, given that you already know the first one's white. 1 mark, 1 mark. Event A is defined as a chance that it will be sunny tomorrow. There's an 18% chance that it will be sunny tomorrow. What's the probability of not A as a percentage? 0.88, Mr. Dueck? How about try that again? Or 82%. Number 3, a summary of a recent survey is shown below. 60% like hamburger, 70 like pizza, 40 like both. You know what? 2 categories and some overlap, especially with percentages. Carly, this is a job for a Venn diagram. You could do this with the OR equation, and it can be done. There's your AND, there's your A, there's your B, solve for, forget it. I find this much more visually clear. Hamburgers, pizza, 40, so that means this is 20. There's my 60% that like hamburgers. That means this is 30. There's my 70% like hamburgers. And it's percents, so what is, if I add up all the percents, Sabina, what does it have to add to? 100, 60, 10%. Oh, there's my neither right there, 10%. It just popped up. Number 4, here's an example of just a generic probability question. I think I'm going to solve this by counting. It says, a game begins with 2 cards being dealt from a standard deck of 52 cards. Okay. To win this game, the next card must be the same or fall between them. If the first 2 cards are a 3 and a 10, what's the probability of winning the game? Okay. I just kind of visualized, there's a 3, there's a 10. Between them I can have a 4, a 5, a 6, a 7, an 8, and a 9. And I think there's 4 of those, 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 1, 2, 3, 4, 5, 6. I think there's 4 to the 6th. 4 times 4 times 4, sorry, not 4 times, 4 plus 4, 4 times 6. Mr. Dueck, nice try. 24 cards. Oh, and how many 3s are left in the deck? 3. How many 10s are left in the deck? 3. How many winning cards are left in the deck grand total? I think 24 plus 3 plus 3. 24 plus 6. I think 30 out of how many cards are left in the deck? 50. That's actually testing the basic definition of the probability, which was, hey, it's the number of successful outcomes divided by the total number of outcomes. We used to always say if you can count it, you can solve it. I think it's 30 out of 50 it is. Number 5, each of the 11 letters of the word mathematics is placed on a separate card. A card is drawn and not replaced. A second card is drawn. What's the probability that both are vowels? So we're going to have vowel, not vowel on the first card. Vowel on the second. Not vowel on the second. Vowel on the second. Not vowel on the second. You know what? They want both vowels, which means I'm just going to fill in this branch here, because that's vowel, vowel. 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 4 out of 11 vowels. Not replaced, so 3 out of 10 vowels. What we want is the probability of vowel 1 and vowel 2. What does and mean? 4 out of 11 times 3 out of 10, 12 out of 110. 6 out of 55, if you went to lowest terms. Number 6, 1 card. How many cards? How many cards? This is not a tree. Tree is separate events. This is about the only time where I either count or I use the OR equation. Event A getting a heart, B getting a face card, C getting a 10. Getting a heart, that I can do 13 out of 52. A or B. This is going to be A plus B minus the overlap.
Please excuse this interruption. This is just to let you know that the internet...
I could use the equation. I just counted. I said, well, there's 13 hearts. How many face cards? 12. That's 25. How many hearts are also face cards that I've counted? Oh, you know what? I am actually using the equation, aren't I? It's going to be 13 out of 52, 12 out of 52, minus, I've counted some cards twice. What's the overlap, Brett? How many hearts are also face cards? Jack, Queen, King. What is 13 plus 12 take away 3? Oh, my child. 13 plus... Yeah, there you go. I don't know if I'm sensing that you didn't do the quiz or not, watching you write things down. We'll leave it alone. Probability of B. I don't know why I went across. That's part E. Part B is... question B is probability of B face card. That would be 12 out of 52. C, getting a 10, 4 out of 52. Not B, 40 out of 52. A and C. Event A is getting a heart, 13 out of 52. Event C is getting a 10, 4 out of 52, minus the overlap. Oh, no, Mr. Dueck, it's not asking for or, it's asking for and. That's dumb. And. What does this mean in English, Brett? This means how many hearts are 10s? How many 10 of hearts are there in the deck? 1 out of 52. I don't need to go to a formula. G, A or not B. How many cards are either hearts or not face cards? Here I think I'll use the equation. Let's see. It's going to be A, 13 out of 52, plus not B, which I have over here, 40 out of 52, minus the overlap. What's the overlap? How many hearts are also not face cards? How many hearts were face cards? 3. So how many hearts are not face cards? 10. 13 and 40 is 43 minus... Is it 33 out of 52? Sorry? 43 out of 52? Makes more sense to me. H, not A and not B. I'm just going to solve this by counting, I think. No, Mr. And means multiply. And means multiply for multiple events. This is one card. This is not a tree. How many cards are not hearts and not face cards? How many cards are not hearts? 39. Of those, how many are also not face cards? Well, there's 3 left in each suit, 3 suits. You know what? I think it's that. It is that. 30 out of 52. Yes? Turn the page. A tetrahedral die has 4 sides. 2 dice are rolled. Use a sample space. For dice, I don't do a tree. Even this 4-sided dice, it's going to be 4 branches, and then each of those is going to have 4 branches, 4 branches, 4 branches, 4 branches. I'm going to do a chart. I'm going to go... because it takes all of 30 seconds. 1, 1, 2, 1, 3, 1, 4, 1. 1, 2, 2, 2, 3, 2, 4, 2. 1, 3, whoop, 2, 3, 3, 3, 4, 3. 1, 4, 2, 4, 3, 4, 4, 4. There's my rolls. Probability that the sum of the... How many outcomes are there? Sum of the 2 dice is equal to 6. 1, 2, 3 out of 16. I see it. Right there. The product of the 2 dice is a multiple of 3. If you multiply them, oh, I guess that means 3 has to go into it. 1, 2, 3, 4, 5, 6, 7. I think it's that combined with that. 7. The number showing up on the first die is greater than the number showing up on the second die. Okay. Am I wrong? Am I wrong? No, yes, no? Right? 3 this way, well, 4 this way, 4 this way, but you're double counting that, so 7, yes? The number showing up on the first die is greater than the number showing up on the second die. Okay, where's my first die? That's I wrote the first die first, so that it's greater than, that's going to be all those, oh, there's that top corner for me. 1, 2, 3, 4, 5, 6, also 7 out of 16. Isn't it 6? Yes, it's also 6 out of 16. The sum of the 2 dice is equal to 6, or the product of the 2 dice is a multiple of 3. I'm just going to count. Let's see, the sum was equal to 6. That was this group here. Or the product is equal to 3. That was this group here. You know what? 1, 2, 3, 4, 5, 6, 7, 8, 9. I could have got there with a formula, but it's 9 out of 16. And then, from last day, a conditional. The first die is 4, given that the sum of the 2 dice is equal to 6. Given that which is going to be the probability of the first is a 4 and the sum equals 6 divided by the probability that the sum equals 6. I already did that the sum equals 6. 3 out of 16. Sitting up there. First die is a 4. Oh, that's that row, isn't it? Is that right, Mr. Dueck? First die is a 4, given that the sum of the 2 dice is equal to 6. So the sum of the 2 dice is equal to 6 is that. First die is a 4. I haven't made a mistake in my chart, have I? No, I have not. Oh, but I don't want first die as a 4. I want first die as a 4 and the sum is equal to 6. I'm sorry, guys. There's the ones where the first die is a 4, but the only one that has both of those is That guy. How many, Vlad? Out of? Not 4, Mr. Dueck. 1 out of 16. Now what? How do I divide by a fraction, flip it and multiply? I'm going to get 1 out of 16 times 16 over 3. Now that I see that, it makes sense. Here's the ones that add to 6. How many of them are there? 3. Of those, how many also have the first dice being a 1? 1 out of 3. But I got it with the conditional probability equation. Give yourself a score, please, out of 19. Can you get this out, please? Because I've decided to nuke the last lesson, I need to nuke a couple of these questions. There's some of these that you will not be able to do. Or if you can't find this, you can just jot these questions down on a separate piece of paper and say, omit these questions, but I gotta go really quick because I'm pressed for time. The ones that you won't be able to do are number 5. Number 13. Number 17. Number 20. Uh, 21. 22. 23. 26. 30. 32. 33. 34. 35. 'So we nuked some there. Those are all using something called the binomial probability distribution, which is way cool, but we're not going to get to it. Last day, we looked at conditional probability. The homework I assigned was from lessons 5 and lesson 6, I believe, if I'm not mistaken. Yes, it was. So first of all, from lesson 5, if you could open your books, please, to page 460-ish. Any of these that you would like me to go over, now is your chance to ask. Yep. Number 1? Yes. Number 1 is easy mathematically. It's tricky grammatically. All right. How many cards? No. How many cards? Tree. Okay. Today we're going to be doing more than 2 cards, and so that's why I'm going to give you a different strategy. But for 2 cards, tree. And it looks like we're talking about queen, not queen, queen, not queen. So I'm going to go like this over here. Queen 1, not queen 1. Queen 2, not queen 2. Queen 2, not queen 2. And I'm pretty sure it's going to be 4 out of 52, 48 out of 52, 3 out of 51, 48 out of 51, 4 out of 51, 47 out of 51. What? Oh, it's with replacement. That makes it even easier. A little more boring. Thank you, Tyler. I think you told this to me last day too, didn't you? Okay, someone did. So it's going to be 4 out of 52 again. Boring. 48 out of 52. 4 out of 52. 48 out of 52, which means they're dependent. Or, sorry, independent. Anyways. Read to me the sentence with the word calculate. It's both divided by the given one. Okay? Let's do the bottom, the given one. Which of these branches have at least one queen? Alex, this branch, or this branch, or this branch? It's going to be in the bottom. 4 out of 52 times 4 out of 52. Can I just write 4 out of 52 squared? Or 4 out of 52, 48 out of 52. Or 48 out of 52, 4 out of 52. You know what? Since that's the same number, I'm just going to multiply this one by 2 because I'm running out of room. Is that all right so far? That's going to be the bottom. It'll be 4 out of 52 times 4 out of 52 plus 4 out of 52 times 40 out of 52 plus 48 out of 52 times 4 out of 52. It's the top I want to talk about. This is where the grammar is weird. 2 queens, given that at least 1 queen. So at least 1 queen, Alex, is these 3. Of those 3, which of those also have 2 queens? Because that's the overlap. That's what's going to be on the top. That's the overlap between 2 queens and at least 1 queen. Well, if you have at least 1 queen and you have to have 2 queens, really it's just 2 queens. That's the overlap. That's it. Weird grammar. And that'll work. Is that okay? Any others from this lesson? Okay, could you turn to the next lesson, which was page, page something or other. Page 468. I can't remember which ones I assigned here, but I did assign some. Which ones do you want me to go over from here? Realizing that your test is at the end of this week sometime. Okay. Well then, let's move on. We're going to finish off the unit today. What we're going to ask today is, let's get away from boring 2-card questions. Poker's played with 5 cards. Or 7. Most of ours are going to be looking at 5 cards because I typed this up before 7-card Texas Hold'em became popular. So what we're going to ask ourselves, Kara, is what if I have more than 2 cards? Is there a different strategy beyond a tree? And there is. Okay. So we're going to use permutations and combinations to create probabilities, which means we're going to be using chooses and factorials and permutations, NPR, NCR. So you absolutely are going to need a calculator out. For experiments with only a few draws from a deck of cards or a pot, it's easiest to calculate using a tree. However, as the number of draws gets larger, the number of branches in the tree increases dramatically, and the tree method becomes very tedious. The use of permutations and combinations offers a more efficient way of calculating probabilities for these multi-draw type experiments. Supposing 2 cards are drawn without replacement. Let's start with a tree, see if we can spot a pattern and a shortcut, and extend it to 5 cards, let's say. Our event is ace, not ace. So let's fill in the branches. How many aces are there in the deck, Spencer? Out of? And that will leave us with 48 out of 52. It's without replacement. So now this would be 3 out of 51, 48 out of 51, and here would be 4 out of 51, 47 out of 51. The probability that both cards are aces is the probability the first card is an ace times the probability that the second card is an ace, given that the first card is an ace. It's that times that. It is 3 out of, sorry, let's start out with the top branch, Mr. Dueck. 4 out of 52 times 3 out of 51, which is 12 over 2652, but I'd like you to reduce that one, please, because this time we are going to start to get answers in lowest terms. I think it's 1 out of 221 or something like that. Okay. One way to do this would be to use combinations. Would be to say, you know what? Here's my bucket. And in the bucket we have aces and not aces. How many aces are there in the deck? How many non-aces are there in the deck? How many aces do I want to choose? How many non-aces do I want to choose? See the drawing? Watch. 4 aces choose 2 and 48 non-aces choose none. To make it a probability, we have to divide by the fact that there is 52 cards, you're choosing 2 of them. By the way, do you remember what is 48 choose 0? 1. I'm going to write it though because it's nice and symmetrical. Try typing that into your calculator and see if you get 1 over 221. Yes? Mr. Dueck, why did you write the 48 choose 0? We didn't really need it. It gives us a handy built-in error check. You may notice, Tyler, if I add the first number here and the first number here, Justin, what is 4 plus 48? And what is 2 plus 0? The first plus first along the top should give you the first on the bottom, and the last plus last plus along the top should give you the last on the bottom. You could also have done this with permutations. I'm not a big fan of the permutation approach. I only use permutations if it's very, 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 very clear to me that order matters, and I don't think order matters for card questions. So I'm going to skip that for a section, and I'm simply going to say, turn the page. We're going to use chooses for card questions if there's more than 2, like a 5-card poker hand. Example 1. 5 cards are drawn without replacement from a shuffled deck of 52 cards. Find the probability that the 5 cards are all spades. Alex, how many cards are we drawing? This is not a tree. You could. In fact, this, because it's all spades, I could do, it's all the same event. I could go 13 out of 52, 12 out of 51, 11 out of 50, 10 out of 49, 8 out of 48. I think that would be, I could do that. Bucket. Spades, not spades. Emily, how many spades are in the deck? How many non-spades? Use the complement. 39. How many spades do I want to choose, Emily? How many non-spades? Sorry? 0? Now, if I just wanted to know how many, it would be 13 choose 5 times 39 choose 0. But I want to figure out the odds, so I have to take how many successes divided by the total number of outcomes. It's going to be 13, choose 5, and 39, choose 0, divided by, from 52 cards, choose 5 of them. What are the odds of getting a spade flush? You know what? It won't change that to a fraction. It gives it to me in scientific notation. Yes? You get this? This is 4.95 times 10 to the negative 4. This is 0.12345. That's the odds of getting a spade flush. How many suits are there? 4? That's the odds of getting a flush. Any flush. Now, you might want to separate out a royal flush, because that's considered a really, really good hand. Whatever, we could. But for now, there's your gambling. That's why a flush is a good hand. Doesn't happen very often. B. 3 spades and 2 hearts. Who plays poker? Is 3 spades and 2 hearts a good hand? No. Should the odds be higher or lower than what we got on A? Should be higher. This is going to be a bucket with 3 categories: spades, hearts, and others, not spades, hearts. Sandalee, how many spades are there in the deck? How many hearts? How many non-spades and hearts? Use the complement. 26. How many spades do they want me to choose? How many hearts? How many others? So it's going to be 13 choose 3 and 13 choose 2 and from 26, Mr. Dueck, choose 0, all divided by 52, choose 5. By the way, if I add up the first numbers along the top row, it'll give me the first number on the bottom row. If I add up the last numbers along the top row, it'll give me the last numbers on the bottom row. Hey, there's my... That'll happen almost all the time. 13, choose 3, and... not 12. 13, choose 2, divided by 52, choose 5. Whoop, that didn't work. Choose 5. You get 0.00858. No, yes? Way better odds than that one. Does that one go as a fraction? Nope. There's limits to what the software can handle. C. There are 3 spades and 2 non-spades. Spades, not spades. Are there any other categories, or is that everything in the deck? I think I got everything covered. Otherwise, I'd have to add an extra thing, but everything is a spade or not a spade. 13, 39. Good, try this one on your own. I got 0.08154. Anyone else want to double check me? So our bucket approach, Vlad, works very well again. The equation kind of pops out. Double check, 13 plus 39 is 52, 3 and 2 is 5. Yes, I haven't missed anything. skip D, try E on your own. By the way, 2 aces and 2 kings. Good poker hand? Okay. You get 0.0608? 6? 0.0609, I guess, if I round it properly? Or am I wrong? Nope, people looking at me. I might have typed it wrong. Oh, geez. I went 13 kings. Good gosh, Mr. Dueck. This seemed way high. Well, that's silly. All my numbers are wrong. Nice. How about 4 aces and 4 kings? And that would leave me with 52, take away 8. Good gosh, Mr. Dueck. 44. So that's going to give me 4, choose 2, 4, choose 2, 44, choose 1. I think I can salvage this, though. Let's see. 4, choose 2, 4, choose 1, 44. Am I going to get an error here? I just might. You get 6.09 times 10 to the negative 4? That's better. It's a good hand, a good poker hand. Turn the page. Three prizes are awarded in a raffle. 100 people hold 1 ticket each. What is the probability that Alice, Ben, and Conchetta win A, B, and C? Win first, second, and third prizes, respectively. Respectively means in that order. So we want Alice to win first, and followed by Ben to win next, and followed by Conchetta to win after Alice and Ben. You can do this with a permutation. How many people are there, Sabina? I think I can just visualize this. What are the odds, because Alice has to win first, what are the odds of her winning? How many Alices are there in the deck? 1. How many cards are there in the deck, grand total? You see, I'm turning it into a card question, yes? $100. And? Okay, she won. Woohoo! How many Bens are there in the deck? Out of? How many cards are there left now in the deck? 99. And? How many Conchettas are there in the deck? 1. I would just do it that way. It is 3 permutate 3 divided by 100 permutate 3. Yeah, that makes way more sense to me. Which is 1 over, I can leave this as a fraction, 100 times 99 times 98, 970, 200, which is also the same as 100 permutate 3. From 100 possibilities, permutate, because the order matters, 3. I'm not going to give you a multi-step question that requires a permutation that you can't just solve by walking down the branch like we just did. C, or B. Now order doesn't matter. Now with 3 people, I think now, Sandali, I'll do a bucket. My bucket's going to have winners and losers. How many winners are there in the deck? Dominique. How many losers are there in the deck? How many winners do we want to choose? How many losers do we want to choose? None. 3 choose 3, and 97 choose 0. All divided by... Dominique, divided by what, do you think? See the equation popping out? Yes? By the way, folks, what is 3 choose 3? 1. What is 97 choose 0? 1. You know what? Let's see this as a fraction. Just find out what is 100 choose 3. What am I going to put on the bottom there? $161,700. Lotto 649 in the BC 49 draw. 6 numbered balls from 49, numbered 1 to 49, are randomly selected without replacement. Before the draw, you select 6 numbers. What's the probability that you win the grand prize? I think we have winners and losers. How many winners are there in the deck? If you want to win the grand prize, how many winners do you have to pick? Kara. How many losers are there in the deck? 43. Now, if you want to win the grand prize, how many of those 6 do you have to choose? How many losers do you want to choose then? What's the equation? 6 choose 6, 43 choose 0, divided by, from 49, choose 6. You know what? The top, once again, works out to 1, doesn't it? So I'm just interested, what is the 49 choose 6? One 13983816. 13983816. Chance of winning 1 in 13,988,816. I think if you match 3, you win a free play. So B, what about only 3? Try that one on your own. I'll do it up here. Let's see if we get to the same thing. Do you get 0.01765? Yeah? Now, they don't tell you the odds of winning the grand prize. They just say chance of winning. And you can win a prize by matching 6 or 5 or 4 or 3. What does or mean? They would calculate each one of those, add them up, and that's what they put. That's what they put. Can you turn in your books, please, to page 474. Page 474. Example 3 at the bottom of the page. A bag of marbles contains 5 red, 3 green. Is it page 470? 473, sorry. 473, duh. A bag of marbles contains 5 red, 3 green, and 6 blue marbles. If a child grabs 3 marbles, how many marbles? I probably could do this with a tree. Yeah, let's try this with chooses. Fine. exactly 2 are blue. Here, I think I could go blue and not blue. How many blue marbles are there in the bag? 6. How many non-blues? 7. How many blues do we want to choose? 2. Isn't it 8? It is 8. Good gosh, Mr. Dueck. Your math is way off today. I want to choose 2 blues. How many non-blues do I have to choose then? Asar, 1. Can you see the equation? 6 choose 2 and 8 choose 1 over what, Asar? 14 choose. Yeah, see the built-in. That's why I always write the zeros, even if I don't need to. I do, so I can use that little quick handy-dandy. Yeah, it's going to be 14 choose 3. What's the answer? By the way, I remember that 8 choose 1 is just 8, so I just typed that too because I'm lazy. You get 0.32967? 0.33? Yes? No? Yeah? Eric, can you read B to me? At least, what does that mean? 1 or? 2 or? 3. What does or mean? Or I could do this. 1 minus the opposite of this question. What's the opposite of 1 or 2 or 3? None. Yeah, I would do 1 minus no blue, which I could do using this, same bucket here, really. 1 minus, from 6 blues, choose how many? None. From the 8 remaining, choose, how many must I choose then, Alex? 3. All over 14, choose 3. This was dumb now. I should have typed the thing properly because I could just go second function edit anyways. Okay, put a 0 there. 8, insert, math, boom. Choose, insert, 3. Divided by 1 minus that. Do you get 0.846? C. Does the order matter in C? Spencer, you know what? This is a permutation. You know what? I can visualize this tree. Let's walk down it. You ready? 3 levels. I can keep track of this. First one is red. Brianna, how many reds are there in the deck in the bag? Out of? And followed by, what does and mean? Second one is green. How many greens are there left in the bag? Out of? And how many blues? Third one's blue. How many blues are left in the bag? Out of? I think that's an easier, cleaner yeah, I could probably do it with a permutation. That's not much typing. And I've reached the point, Vlad, where if it's a fairly simple tree, I can just imagine it without drawing the silly thing. 15 times 6 on the top, divided by bracket 14 times 13 times 12 on the bottom. 15 out of 364, I think. Is that right? Anybody else? Do you get 0.0412? How is D different from C? Read D. Ellen, I can use buckets here, and I would here. Because if I didn't use a bucket, I would have to say it could be red on the first, green on the second, blue on the third, or green on the first, blue on the second, red on the... Or I'd have to look at every possible ordered combination to get all the ors. Or means, that's a lot of trees. No, here is where the bucket really shines. So here's my bucket, and now I'm going to have red, blue, and green. How many reds? 5. How many greens? 3. How many blues? 6. How many of each one do I want to choose here, Carly? How many of each one do I want to choose here? 1. 5, choose 1. 6, choose 1. 3, choose 1. By the way, 5 choose 1 is 5. 6 choose 1 is 6. 3 choose 1 is 3. I'd probably just type that. But divided by what? Choose what? 14 choose 3. 5 times 6 times 3 divided by 14. Choose 3. 45 out of 182. Turn the page. Maybe I will next class. What's your homework? Number 1. That's a single marble tree, or visualize it. Number 2, try it with combinations if you want. Although for permutations, first and second, I would just multiply down the tree. 3 is good. 4A is good. 4B is good. Skip C. 4D is good. 4E is good. Yeah. 9A, 9C, and we'll pause there. You got about 20 minutes left, so you can work on the homework. We are done the unit.